Sine of x times the negative sine squared of x is the negative sine cubed of x. All right? Sine times sine squared is sine cubed. We still got that negative. All right? That's what we mean by simplifying. Now that is one question. We need to try some more because every question will not look exactly like that one did. Here's the next one. All done? All right, so the key here is knowing what's in your toolbox, all those identities, and using those tools to try to get this from 3 functions, sine, cosine, and cotangent, down to as few functions as possible, hopefully only 1. So does anybody see something that's jumping out at you as something we could do really easily? Vaishu? Good. Convert cotangent of x to cosine of x divided by the sine of x. That is a quotient identity that we wrote down earlier. I haven't changed anything else yet. Everything else is just coming along with me for the ride right now. All right? Now, long time ago, back in elementary school, you guys learned how to add fractions. And you learned that when I have a different denominator in one from the other one, that I can't add them together. But you also learned that we can make these 2 fractions have the same denominator. How do I make the first fraction in black have the same denominator as the second fraction in pink? Find a GCF, all right? And the GCF would need to have both of these in it. So someone said multiply by the sine of x. But I can't just change the denominator, right? I have to multiply both the denominator and the numerator by the same thing. So I'm going to get the same denominator over here on my originally black fraction. But to make the denominator the same on the other one, what do I need to multiply by here? 1 plus the cosine of x. It's okay. 1 plus the cosine of x. All right, so now we need to simplify. We're going to have the same denominator underneath both of them. We don't need to distribute that. You can if you want to, but we may end up having to factor it again. So just leave it alone until we see what happens next. So this is going to be the denominator under the entire numerator that we're now going to combine. What is the sine of x times the sine of x? Sine squared of x. So I multiplied these together and I got sine squared of x. What's the cosine of x times 1? Cosine of x. And what's the cosine of x times the cosine of x? Cosine squared of x. Okay. Now, it looks more complicated than it did when we started, but believe it or not, we are 2 steps away from making this pretty nice. All right? Jules, do you have a suggestion? Sorry, I thought I saw your hand go up. Okay. Let me go to Brian for this one then. Interesting. They were not right next to each other, but we have this thing called the commutative property of addition that allows us to add things in any order we want to. And the sine squared of x plus the cosine squared of x, we have an identity for that. It's 1. All right? So we get 1 plus the cosine of x divided by, my denominator has not changed. All right? So that was one step. Use the Pythagorean identity. Second step, what can I do now? Simplify. If I divide one factor by a factor that it's equal to, factor means things that are multiplied, not just added or subtracted, I get 1 divided by the sine of x, which is equal to cosecant. So we took that big expression that we had to begin with, and we've simplified it down into one nice little trig function. All right, so that's 2. Here's a third one. Once you get the hang of this, it's a very satisfying thing to do. Taking things that are not pretty and making them prettier is a thing that we like to do as human beings. That's what we're doing right now. Yes? Real quick, just real quick, because everybody's trying to copy that right now. All right, and that's equal to cosecant. Your first step on this one is going to be remarkably similar to the first step on the last one. What do you guys see that I could trade out pretty easily? Cotangent. We did that last time. I can still do it now. Trade out cotangent with its quotient identity, which you guys told me last time was cosine over sine. Nothing else is changing in this step. As you practice these more, you'll start being able to skip steps, just like you started being able to skip steps when you first learned to solve equations. But you got to walk before you can run. Who's got an idea for the next step? Jules?
Can you distribute the... Can you distribute the cosine?
By distribute, you mean multiply cosine times cosine?
Wait, no, would you take the sine from the denominator?
And do what with it? Right. Good. Jules is right. This isn't an equation, but we like to solve equations. We've gotten used to it. There's no equal sign here, so we're just simplifying, working with what we have. Brian?
Can you cancel the signs?
Cancel the signs. So take this sign and cancel it out with that one. Can't do that because it's 2 separate fractions. Kate?
You're going to multiply the left side, the top and the bottom,
Okay.
by sine of x.
And why are you doing that, Kate?
So it has a common denominator.
All right, so just like in the last problem, we cannot add or subtract fractions unless we have a common denominator. So to get a common denominator, we can multiply, like we did last time, by the sine of x over the sine of x, which gives me the sine squared of x divided by the sine of x plus the cosine squared of x divided by the sine of x. And you guys know that when I add these 2 fractions together, I'm still going to have a sine of x on the bottom. But the sine squared of x and the cosine squared of x, just like last problem we did, is equal to 1. That's Pythagorean identity. Cosine squared plus sine squared is equal to 1. Jules?
So you could, just looking at to the right of the addition sign, just have, you could put those cosines together initially as just cosine of x squared over sine of x?
Mm-hmm. Yes. All right. Grant?
I'm confused on how you get cosine squared. Like, I know you multiply sine of x, then you now multiply it.
So here I was only multiplying the sine of x over the sine of x by this fraction. Over here I got cosine squared because from the beginning I had a cosine times a cotangent. This is cotangent, but I didn't multiply those together until I got right here. Cosine times cosine is cosine squared. And that came from way up here where I had cosine, still had cosine, I changed cotangent to cosine over sine, and I multiplied these together to get cosine squared.
Oh, so you don't have to multiply times sine of x because it's multiplication. Like, you're not going to count the denominator.
I already had a sine of x here for the denominator, so I just needed one here, and that's why I multiplied just that side. Alec?
Would you keep it as 1 over sine of x or change it like cosecant?
Yeah, I am going to simplify that. I just took a little sidetrack there.
On a test, do you have to simplify it?
You want to make it as simple as possible. This is not as simple as this. So we want to go with this one. All right? Okay. Next one. This one is actually the easiest one we've done so far. You got to take a step back before you get overwhelmed and look at what we have here.
There's one. Oh, I'm still writing it down. Is that a fish?
Oh, good question. All right, so on the top, we've seen theta before, right?
Jesus.
On the bottom, what's that little fish-looking thing? That's alpha. That's alpha. Okay? Remember that identities work no matter what the variable is. So that means we can trade the variable out with something else, and the identities are still going to work. So don't let different letters, different symbols fool you. It's still doing the same thing as it did before. Has anyone figured out to the bottom part of that yet?
Oh, 1.
Yeah, you should get that one. We've done it 4 times now. So the bottom, cosine squared of alpha plus sine squared of alpha is 1. What about the top? Hold on, that was a big jumble mess. All right, Saurav, why is that 1?
You have tan squared, well, you have 1 plus tan squared of x equals secant squared, so you subtract the tan squared of x, and you get secant squared of x minus tan squared of x equals 1.
Good. So we just need to subtract this from both sides. If you missed what he was saying there, we're trying to get secant squared minus tangent squared, and we can do that by subtracting in our Pythagorean identity that we wrote down. 1 equals the secant squared of theta minus the tangent squared of theta. So we just replace in our equation up here, or expression I should say, all of that with a 1. And like I said, easiest one we've done so far. But you got to know your Pythagorean identities. Now, one thing that is not true, you can't say the sine squared of theta plus the cosine squared of alpha equals 1. That is not true. What makes that one an issue? Alexis, say that for everybody.
Different angles.
Different angles. We're working with different angles, not the same one. So that does not work. Never, ever, ever. Okay. Last example. Do not do this. That is not allowed. That's like saying 1 plus 2 divided by 2 equals 1. You can't do that. All right? There are lots of other things you can do, and Kate's right. If it was multiplying, you could do that, but this is not multiplying. That's the subtraction sign. All right, so Jules just suggested replacing them all with sines and cosines. That can help. That's a good strategy, because if you get rid of the secants and the tangents, there's more that we can do with sine and cosine than there is that we can do with secants and tangents. The correct solution to this, and then we'll see who has some methods to get there. The correct solution to this is 1 minus the sine of y. That's correct. 1 minus the sine of y. So now the question is, first of all, did anybody get that? Good. All right. Second of all, what are the methods we used? Vaishu, can you tell us your first step? Okay, so I'm going to use Vaishu's method. It is not the only correct method. So if you did something different, do not erase what you've done. What Vaishu's saying is that she converted all of these to their reciprocal functions, which is what Jules was suggesting a second ago. And then in the denominator, we have 1 over cosine of y again. All right, so that is a fine first step. It's not the only possible one. What'd you do after that?
Well, since the cosines have the top equation has the same denominator,
Okay.
I just combine them together to say 1 minus sin y over cosine.
Good. So she put all of this together and said 1 minus the sine of y divided by the cosine of y, and then she left the bottom alone for now. All right, so we're just subtracting, have like denominators, we're allowed to do that. All right, so what did you do after that, Vaishu?
It's like a complex fraction, so I just left the bottoms.
Okay, so when we divide complex fractions, we can change them into multiplication. So 1 minus the sine of y divided by the cosine of y, instead of divided by times, but like she said, we have to flip the second fraction to its reciprocal. Division is the same thing as multiplying by the reciprocal. So what happened after that? And we're left with just that, divided by 1, which is the same thing. All right, so that's one method. Who has another method that gave you the same answer but took a different route to get there? Nobody? Everybody did the same thing?
She did something, and it was smart.
It was smart?
Yes.
She just doesn't want to share it?
I will share it if she doesn't want to. I liked it.
All right. So let me write this down real quick, Hannah. This is what we had. Tell me what Kate did that was so smart that we need to share it.
Well, she split it all up. So she did secant of y over secant of y.
Whoopsie. All right.
Minus tangent of y over secant of y.
Interesting.
And then Kate's smart brain knew that secant of y over secant of y equaled 1.
Okay.
And then she did turned it into the cosines and the sines and stuff.
And then we did the cosine sine stuff. Whoops, that was wrong. So that's that. And then divided by... All right, so this works too. In the end, we get the same answer because we're still going to have the 1. That's going to be part of our answer. And then we're going to have to take this stuff and do sine of y over cosine of y times cosine of y over 1, and we get sine. So all of this stuff simplifies down just to the sine. So 1 minus sine of y. Okay? Now that is a legal move. 1 plus 3 over 2 is the same thing as 1/2 plus 3/2. 1/2 plus 3/2 is 4/2, which is 2, and 1 plus 3 is 4 divided by 2 is 2. So this is legal. If you're ever not sure if what you're doing is legal or not, try with numbers, an elementary school problem. Elementary school stuff works in high school. It just looks different. All right?